Hello students, in this video we shall continue with the concept of NDFSM construction. Along with that, I will explain the concept of string acceptance by writing a instantaneous description for string acceptance. Let us take our first example. Let us to consider a language that has got strings of A's and B's. Okay, and we have to construct both DFSM and NDFSM for that language. But there is a condition. What is that condition? That the language should have substring AB at the end. In other words, we are talking about a language that ends with string AB. Once we construct the DFSMs and the NDFSMs for this string, for this language, we have to check whether string baaab and string aabbab is accepted. And how do we check this acceptance concept? It is by writing a instantaneous description. So first let us construct the DFSMs and NFSMs and then go ahead with writing instantaneous descriptions for both the strings which are specified in this question. The first I will draw the DFSM. Okay, we know that the minimum string is AB. And the alphabet sigma is equal to A comma B. We have Q0 state. When we see a A, we go to Q1 state. On Q1 state, when we see a B, we go to Q2 state. And Q2 state is considered as our final state. So in Q0, if you see a B, you remain in Q0 itself. In Q1, if you see a A, you remain in Q1. In Q2, if you see a A, then you go back to Q1 state, and Q2, if you see a B, you go back to Q0 state. Therefore, transitions were Q0, and Q0 when you saw a A, you go to Q1. When you see a B, you remain in Q0. In Q1 state, when you saw A, you go to Q1 state or remain in Q1 state. Whereas when you see a B, you go to Q2 state. And Q2 state was our final state. So in Q2 state, if we see a A, we go back to Q1 state. And in case you see a B, you go back to Q0 state. Now, the NFSM construction for the same. How is that? It is a string which ends with AB. Prior to that, it can have any number of A's and B's. Therefore, we have Q0 state. We give an A, go to Q1 state. In Q1 state, we give a B. We go to Q2 state. And Q2 state is our final state. So we are done with this part. We have to only worry about this part now. So on Q0 state, we have any number of A's and B's. Therefore, transitions are given as A and B. On Q0 state, which is our start state, when we see a A, you can go to Q1 state or you can remain in Q0 state. And when you see a B, you remain in Q0 state. Then in Q1 state, we don't have any transition defined for A, whereas when you see a B, you go to Q2 state. And Q2 state is our final state, but we do not have any transitions defined. Therefore, we write a 5. So this is the NFSM for a language that ends with string AB. Now let us consider the string baaab and see whether it is accepted by this language. It is supposed to be accepted by this language because when you check the string visually, you can see that it ends with AB, right? It ends with AB. Okay. But let us check with the concept of instantaneous description. So I'll redraw the NFSM. Okay, and then we'll try out the instantaneous description. Now for instantaneous description, you consider the state, the start state and the entire string here. So if we have got B, A, B. Now, how do we write? On Q0 state, when you see the symbol A, to which state do you go? In Q0 state, when you see a A, when you see a B, you remain in Q0 state. Now we finished up with this symbol. So what is the next string which is remaining? A, B. Okay. Now you take Q0 state and you take input A. What happens? You can go to two states. What are those two states? You can go to Q0 state or you can go to Q1 state. Okay. We have finished checking this input symbol A. So what is remaining to be checked? It is AAB string, and in Q1 also it is AAB string. Okay, we'll take one leaf, that is Q0 state. On Q0 state, when you see a A, again you go to two states. So you finish reading this symbol. You can remain in Q0 or you can go to Q1, and the string which is remaining to be read is AB in both the cases. Okay. We'll take one more subtree. On Q0 state, we read a A. What will happen? Q0, and will go to Q1. So the remaining string, once we read this A, is B, and here also it is B. Okay. In Q0 state, when you read a B, where will you go? It is Q0 state itself. We finish traversing here. And in Q1 state, if you read a B, where do you go? You go to Q2 state. But we have a right subtree which was pending here. That is, in Q1 state, if you read a Q1 state, when you read a, do we have any transition here? Therefore, it is 5, and 5 is supposed to be our dead configuration, because you don't have a transition which is written for this. Similarly, here in Q1, when you read a, do we have a transition there? We do not have a transition. So even this leads to 5, which is a dead configuration. This tells us that in case we were to traverse this path, then it does not allow us to traverse further because there is a no transition defined. In case we were to traverse this path, then we will end up with a dead configuration. Whereas if we had traversed this path, then we would have reached the final state. Therefore, the path traversal is given as, we had Q0 state. From Q0 state we went to again a Q0 state. Again we remained in Q0 state. Again we had to remain in Q0 state. Then we went to Q1 state, and then we went to Q2 state. Therefore, this was with the input B, A, B, and we reached final state. Let us take the second string which is given to us. That is AAB. We know that this string also is accepted by the NFSM. So we'll quickly draw the NFSM. And we'll traverse it. So we start the string traversal in Q0 state and the entire string. So in Q0 state, when you see a, you go to two states, that is Q0 and Q1. And now the remaining string which is to be checked is A, B, B, A, B. So in both the places you write the remaining string to be traversed. Then take the second character of the string. That is in Q0 state you are seeing an A. Again we go to two states, Q0 and Q1. So the remaining string which is to be written is BB, AB, and here BB, AB. Okay. Now in Q0 state, when you see a B, you go to Q0 state, and the remaining string which is present for us or remaining for us to traverse check is BAB. In Q0 state, again you see a B. So remaining is AB. In Q0 state, the next symbol which you check is A. So you go to two state, that is Q0 and Q1. And the remaining string to check is B. Now in Q0 state, if you check a B, you go to Q0 state. Okay. In Q1 state, if you check a B, you go to Q2 state. So here in Q1 state, we come back, we traverse back. Now in Q1 state, when you see a B, you go to Q2 state. And in Q2 state, what is remaining here? They finished with this string. What is remaining here? B, A, B. So in Q2 state, if you see a B, do we have a transition specified? We do not have a transition specified, so it is dead configuration. Okay, we come back here. In Q1 state, when you see a, do we have a transition specified? No, we do not have a transition specified. So this leads to again 5. So this is a dead configuration. So in order to reach the final state, we will go from Q1, we read a symbol A and go to Q0 state. We remain in Q0 state. In Q0 state, we read the second symbol which is specified, that is A, and we have to remain in Q0 state. In Q0 state, when we read the symbol B, again we remain in the Q0 state. In the Q0 state, we read the next symbol, that is B. We remain in the Q0 state and we read the next symbol A. On reading A, we go to Q1 state, and in Q1 state we read a B and we reach the final state. Therefore, the traversal is given by Q0, you read a, remain in Q0. In Q0 you read a, you remain in Q0. Q0 you read a B, remain in Q0. Again you read a B, remain in Q0. Again you read a, go to Q1. And then you read a B and go to Q2. This is the concept of instantaneous description. Okay. We shall take the second example of NDFSM construction for strings of A's and B's. Therefore, sigma is equal to A, B. That contains a substring baabb. We know that a substring can occur anywhere. It can occur at the beginning of the string, it can occur in the middle of a string, or it can occur at the end of the string. Okay. So when we are constructing our NDFSM, we see the format baabb is our substring. Okay. Before baabb, we can have any number of A's and B's, and after baabb, we can have any number of A's and B's. Therefore, NDFSM will be equal to, we have Q0, we see our first B character, go to state Q1. We see our second character, go to state Q2. And we see the third character, that is B, and go to state Q3. Q3 is our final state. So we have checked this part. What about prior to this BAB? We can have any number of A's and B's. And what about after BAB? We can have any number of A's and B's. By any number of A's and B's, we mean 0 or more A's and B's. Okay. Let us write the quintuple representation, which is given as M is equal to, we have 4 states, Q0, Q1, Q2 and Q3. Sigma is equal to A comma B. We'll list out all the transitions later. Q0 is our start state and Q3 is the final state. So transitions are given as A and B. Q0 was our start state, so on reading A remains in Q0. Q0 on reading B can go to 2 states, that is can remain in Q0 or go to Q1 state. Q1 state, we have a transition only defined for A, that is goes to Q2 state, whereas no transition is defined when it sees a B. Q2 state, there is no transition defined for A input, whereas when it sees a B, it goes to Q3 state. And Q3 state is our final state. Therefore, if it sees a A, it remains in the same state. When it sees a B, it also remains in the same state for B. We shall check the instantaneous description for the string bbaba. So if we have to see here, so on Q0 state, we are supposed to check the entire string. So on Q0 state, we check the first input, B. Therefore, if you see a B, you go to 2 states. That is Q0 state, or you can go to Q1 state. And the remaining string, this first character is processed. So the remaining string which you have to process is baabb. Okay. Now in Q0 state, again you see a symbol B. Therefore, you will go to 2 states here. You can go to 2 states. You can remain in Q0 state or go to Q1 state. So this is processed. So the 3 symbols which are remaining is ABA. Here also ABA. Now in Q0 state, if you see a A, then you go to Q0 state. And the remaining string which is to be processed is BA. In Q0 state, if you see a B, you go to 2 states, that is Q0 state, or you can go to Q1 state. So remaining string to be processed is A and E. And Q0 state, if you see a A, you go to Q0 state itself. You finish traversing the string here. Therefore, the last state which you see is Q0 state. In Q1 state, if you see a A, you go to Q2 state, and the last state which we see here is a Q2 state in this path. Now let us traverse back. We have to come back here. In Q1 state, when you see a A, where will you go? You go to Q2 state. So I finish processing the symbols. So the 2 symbols which are remaining is BA. On Q2 state, when you see a B, you go to Q3 state. This is processed. And on Q3 state, when you see a A, you remain in Q3 state. So here you finish processing the entire string. Another one path is remaining, that is on Q1 state. When you see a B, there is no transition which is defined for this. Therefore, this will be a dead configuration. Therefore, when we are to see here, we see that we reach a final state if we traverse this path. Come here, then we go to Q1 state, then we go to Q2 state, then we go to Q3 state, and finally remain in Q3 state, which is our final state. Therefore, in Q0 state, when you see a B, you remain in Q0 state. When you see a B again, you go to Q1 state. Q1 state, when you see a, you go to Q2 state. In Q2 state, when you see a B, you go to Q3 state. And Q3 state, when you see a, you remain in Q3 state. You have finished traversing the string BB, AB, A. And the last state which you see here, if you use this path, is Q3 state. And since we know Q3 state is our final state, therefore string BB, ABA is accepted.